Art of programming. And it is an art because it's not something that can be taught without an awful lot of practice. So some people may have a natural aptitude for programming, others may start more slowly, but everyone needs to practice, practice, practice. And I will say this very clearly. It's impossible to learn how to program without doing an awful lot of practice. We'll give you lots of exercises to do both during these lectures and in the labs and in your own time. If you don't do these exercises, you will not learn how to program. That is a stone cold fact. Like learning to drive, like learning to ride a bike, like learning any skill, you need to do it yourself hands-on. Nobody can teach you how to program. We can help you to learn, and we'll certainly do everything we can to facilitate that. But programming is very much a self-driven process, and you need to be able to cope with failure and making mistakes, because that is inherent to learning. Try stuff out, work out why it's not working, learn from your mistakes. You won't break anything. So I would say that the most important aspect of programming is to be clear on what it is you're trying to achieve before you even set hands on a keyboard. The first stage of this is to make sure that you actually understand the problem. What exactly is the problem that you're trying to solve, or the question that you're trying to answer? Because a lot of programs are basically trying to answer a question. What's the biggest number in this list of salaries? What's the best route to get from A to B? And so on. And if you try to jump straight into coding without having a clear idea of what you're trying to achieve, then you will fail. Without a plan, you will fail. Programming is about taking a plan and essentially explaining it to the computer in the form of code that it can understand. So you're taking a strategy that's written down in English and converting it into a machine-readable program, and that is what coding is about. You then need to run and test and amend your program until the outcome is what you expected to see. Now, of course, as a result of running your program, you might also have to go back and change the basic plan in the light of new information or new insights. And of course, that's fine. The important thing to emphasize is that we won't be writing any code for the first couple of weeks of this module. There's no point until we have a clear idea of how to conceptualize, design and phrase our plans or our algorithms. Of course, we can't hope to become experts in this in 2 weeks, but we can at least lay the foundations. So we'll be looking at how to understand a problem, how to analyze it, and how to design algorithms to solve problems. So as I said earlier, a program is simply an explanation of an algorithm phrased in a manner that a computer can understand. So Donald Knuth, one of the most famous and influential computer scientists of our day, emphasizes that you need to be utterly unambiguous and clear when you're explaining your plan to the computer. So in spoken English, we can get away with sloppy constructions and errors of grammar because the compensating mechanisms in our brains allow us to extract meaning from imperfect phrasing. Computers don't have these mechanisms, so we need to be totally clear. So, we hear the term computational thinking a lot nowadays, and if you've done GCSE computer science, you'll be particularly familiar with it. Essentially, this is about developing a mindset that allows you to naturally think about the world in algorithmic terms. It's about taking a problem and breaking it down into smaller parts that are individually solvable. So it's less about writing code and more about seeing the world as a series of processes that act on information and how these processes can be fitted together to achieve a desired outcome. At the heart of computational thinking is the algorithm, and the first stage of developing an algorithm is to understand the problem, the analysis.